for him. That'd be good medicine.
You should.
We should do that.
Say it again.
Next time we can all talk to him. So I wanted to talk about this set because I actually had really good questions about set structure and how to deal with it. I don't think the questions were directed first at this, but I think it is this. So you have this set HA, which is the set of X belonging to G, such that it's this set right here. And you have to prove that this set was a subgroup, right? So one of the ways to think about a set, so one of the first little instructions I got when I was finally willing to listen was, every time you have a set, you should imagine the set as being a club. And the club has members in it. So there's a bouncer at the front, and it's evaluating every element in the big group G and asking, is it a member of this club or not? Okay? So the members of this club, if you want to say it in words, are, it's going to be the set of X and G that commute with A. So imagine the bouncer standing in front saying, do you commute with A? You don't? You're out. Do you commute with A? You're in. So anybody who commutes with A is in, anybody who doesn't commute with A is out. Now you can also think of a real, when you get a set, you should also think of a real set where you can create this thing. And a good example I think I was using with you guys just one by one was to think of D3, because D4 is big. So D3, dihedral group, the rotations and the reflections of the triangle. So you can just pluck one element out of that set, and that's your A. So I don't remember all the notation we used. I think, for example, create a for example. And then actually construct H. What will HA look like in this case? I don't know if any of you did this.
Rotation 3, right?
Huh?
Rotation 3 automatically.
Right, so we know H row 1 would be rotation 2 and 3, right? They both will commute because they, right, this is just rows, these are the cyclic elements. They're the, right, so those two will be in there. Anything else? Does anything else commute with the first rotation?
E?
Yep, E will be in there. And that's probably it. I don't think the reflections, I don't remember what the group looks like, but the commuter table, do you have it in front of you? I think that's it. Right. My E looks like a row. So that's it, right? So now I have a better handle of what this HA is. I mean, so I've created an exact example. When I chose the example, why didn't I just choose Z6? I could just have chosen Z6. I mean, Z6 is so super easy. Why would I go to the table that I actually have to go look up things and think about? Why would I use this example?
Z6 is already abelian.
That's the problem, right? Everything commutes. So every time I construct anything, I don't get anything interesting. I don't actually get the bouncer never bounced anyone out. So everybody's in. So it's not an interesting example. It didn't teach me anything. So this is a good way to start when the whole, just the first thing you can do before you get started. And for me, I was an impatient person. So these kind of exercises at the beginning were annoying because I felt like they were taking away time for me getting my proof done. And I remember the German girl telling me, so can you give me an example of the group? And I'm just like, get on with it. Just tell me how to do the proof. I remember feeling that way. I don't know if you feel that way, but I honestly felt that way. Like she was keeping me from doing the proof. And really what she was doing, she's helping me think. She's trying to show me how to structure it so that when I get to the actual proof part, it starts rolling out. So that's the first trick, that you have to actually write this thing out. Okay, then the second piece of this is to go through the steps of showing the pieces. So is this clear? How I would do this anytime you have a set. Anytime you have a set, just ask yourself if you can create an example of what this beast will look like for a real thing that you can see. And maybe what I'll do is I'll start giving you points in the rubric for doing that. So if you get the whole thing done, that's fine. But if you don't, if you have these pieces, then you have something there where you've thought about it. That'd be a nice way to get it.
I'm not following you with this. Where does row 2 fit into HA?
Okay, so HA,
Yeah.
A was fixed in that problem, right?
A is row 1.
So G was given, G is arbitrary. A was a fixed element of G. Right? Right, in your problem, in the number 51. So this is the set, right?
In this problem.
Right. So I asked myself, can I take a group G? Can I come up with an example of a group G and an element A and create this HA so I can see what it might look like? So I decided, you're absolutely right. If I had been doing these pre-planned, I probably would have all this. I just chose my G to be D3, and I chose my A to be row 1, and I just tried to create what this set looks like. So I have to think about what this means, right? What this set means, it's the elements in the big group that commute with my selected guy. I just selected row 1 and I fixed it, right? So then I went to this D3, and I don't have the table in front of me. So I'm relying on Kristen she nodded her head and said, that's it. So if you go back to the table and look at all those elements in the big group that commuted with row 1, what are they? Well, the identity commutes with row 1 because the identity commutes with everything. So it got in. Row 1 commutes with row 1, right? Row 1 star row 1 is row 1 star row 1. That one commutes with itself. So that one's in there. Rotation 2 commutes with the rotation 1. You can just go check it. Right? Rotation twice, and then rotation 1 gives it. Rotating in the different orders doesn't change the end outcome, right? And the third rotation also doesn't matter. That's it. If you go to the table, I think we used Muse, or whatever we used for the other the symmetries.
Why? Is there any reason why you chose that particular order to enumerate the elements?
No, this is what came to my mind, right?
Okay.
I can make it look nice if you want to.
Oh, it looks nice.
There's no reason. The order in a set, the way you line up, unless you tell someone I have an ordering on my set, it doesn't matter. So these two things mean the same thing. It wasn't me. I think somebody said row 2 commutes with row 1. That was the first thing I think somebody said it. It was him, right?
Yeah.
I said E after you already had row 3, so that was on me.
All right. Any other questions?
This is in D4, right? Since we have a row 3, it would need.
Oh yeah, we don't have a row 3. I was kind of
Because then
thinking
row
that.
3 is identity.
Yeah.
Correct.
So
Thank you. Okay.
we'll only have a row 1 and row 2.
Yeah.
It's like when my sister-in-law came to take care of my 3 cats, and I asked her how are the cats, and she said your 4 cats are fine. There's a 4th cat? I only have 3. It's like Minecraft. It spawned. Does this help? Just at the beginning of anything where you have a set, and they'll get more complicated. So it's a really good idea to do this. And if you can't do it, that's when you text me and say, I was trying to think of an example of a set like this, and I couldn't think of anything. Because until that's clear, you're not going to be able to move on. So it gives you a structure of something that you're supposed to do in a certain order. Okay, any questions on this? Now let's line up now what you have to do to actually, resolve the proof. And then I'll split you up into groups, and this will count as your in-class assignment that we were supposed to have done last week. So that way you're working in class to do this. Okay. Okay, this closed property means that you got 2 people in the club, they hang out together, their couple is in the club too, right? So that's what you want to show. So let B and C belong to the club. They're in. Show when they pair, What does it mean for B star C to be in the club? Well, B star C, they came as a couple. They were holding hands. They met the bouncer. They had to satisfy the requirement of being in the club. B star C has to also commute with A. So the bouncer asked them, you guys holding hands the whole night? Because if you're holding hands, you guys both better commute with A. And from here on out, from the feedback that I saw from you, the process of doing it was fun. It was just setting up what exactly it is you needed to show. So why don't I have you go show this piece together as a group. So and then turn in your work, one per group. And then go on and show the other two pieces. Is E in the club? Identity comes along. Bouncer says, who are you? I'm special. I'm the identity of the group. So you're not special unless you satisfy the criteria of being in this club. So you have to show E actually belongs to the club. Second and third, if B belongs to the club, B got in. B's already in there. But B says, hey, my twin brother's coming. He's my twin. Can't he just come in because he's my twin? No. He's got to also satisfy the criteria of being in the club. So B inverse has to satisfy this condition too. Or else the bouncer bounce him out. I think I used the example of the criteria of a club being you have to be between the ages of 18 and 25, and whoever I was on the phone with that said, I think we're both out. We're not in the club. So it's a restriction. It's not everybody in the group. It's just some of you are allowed in.
BC is arbitrary, but I mean that XY for one.
Yeah, so when I say let B and C be and HA, I arbitrarily chose two people in the club. They're stuck in the middle.
HK.
Good luck working on that.